In this video, I want to go over the bend points of the TPTRed range shaft. What I did for this video is I used a 17 low and a 17 high in the exact same head. I just put it on a standard fit of 9 degrees for this particular shaft. I wasn't interested in optimizing. I was really just interested in trying to get 5 shots with each one as close to the center as I could. And so I took these 5 shots of each one. I tried to keep the speeds exactly the same so that we'd have the best chance to get to see what each shaft would actually do. Now keep in mind, I'm not a robot, so these are a little bit different than I would see on a robot. But we can look at that right there. The 17 low shaft, you can see I was 1 millimeter up on average, so I did get some higher launches than a robot would have seen if we were hitting exactly in the middle. Then hit it pretty zeroed and a little off the toe, which actually generally lowers it because these balls would draw just a touch more than the other one. So we didn't get a big difference, and I wouldn't even see a great big difference off of a robot. I might see a degree to a degree and a half difference in launch, which I believe is about right on a robot. And you can see here the launch angle of both those shafts. I was able to launch it a bit higher with the 17 and a bit lower. Now that's only technically a half a degree, but again, I'm not a robot. And the tendency was to hit it a bit higher with the high than it was the low. And when we're fine tuning a player, that's really what we're after. Where's their impact location and what are we trying to get them to do? Launch the ball a little bit higher or lower. You can see that I was able to get the attack angle a little bit more up on that high range, which generally would add to, dynamic loft being a little bit higher. You can see it is a little, I think they're both actually pretty close to the same on this one. The low was a little bit lower, like 0.4, and so you can kind of see that's where that comes. There's a little bit more uptick to the attack angle. We got the same speeds, we got the same club pass. You can see on the high that it did shut the face just a little bit more, and we can kind of go, the bend point was a little more flex, the face was a little more forward of my hands on the high than the low, and so that tended to shut the face just a little bit. We can see here the spins were pretty close to the same. Generally on the high I would see a little bit more spin, and I got a little bit more spin off of that one, maybe 100 or 200 on the flight, I would say, between the two on a ball spin. And you can see I got a couple of them right there, very low spin right on that one. And take this low spin out there, and we look at those spins, and again we got about 100. That's about what I'd say, 100 to 200 if I would put them on a robot. So again, we're really fine-tuning the ability to get the spins exactly the way we want them when we use these shafts. So you can kind of tell that that's the way that happened. If we looked at the trajectories of them, you can see the high had a little bit more draw bias to it. Again, that's probably the kick more forward, and the face was just a little more shut. And I was trying to, again, be exact as I could on just the impact location. I wasn't even paying attention. I actually did all this indoors, so I couldn't even see the ball flight, and I didn't look up at the monitor either. And I just wanted to make sure I was trying to get it in the center as much as possible. And so that's what came out. As a general rule, with a little bit, higher torque, if I was swinging full speed, this higher torque, maybe that one would have leaked a little bit more right. But trying to keep these speeds down to that, it probably gave me more of an effect of a person that was just stopping the shaft and feeling it kick a little bit more. So pretty valid little quick study on that and understanding the bend points. Now I'll show you a situation where I run into occasionally where this kick point will drive a little bit lower simply because we hit it lower in the face, versus then I can get a higher ball flight out of the low when that person's deflection doesn't go down as much, and they turn around and hit a little higher in the face, get a little higher launch. So you got to watch for that too. So let's go over and I'll show you one of those. When we talk about deflection and droop, we're just simply talking about which axis the shaft is bending around. When we look at this picture on the left, that is deflection. We're going to look at this face-on part of the club and see this axis, and you can see that shaft, the yellow line, would be a shaft that is dead straight. You can see the club is bending ahead of that line, which we call lead deflection. If the shaft were bent backwards and the head was behind the line, we would call that lag deflection. You're never going to see an impact position where this is in lag. It's always going to be in lead. It's just how much lead are we going to have. On the right, this is a depiction of droop. So how much is this shaft going to bend below that line is how much it's going to droop. So deflection on the left, droop on the right. So as we move forward, you can start to see how important it is to understand which shaft does what. In the TPTRed range series, we have in this video, we have the 17 high and the 17 low. And so the 17 high is going to have a lower kick point. It's going to be a little softer down here, so we're going to get more lead deflection to help kick the ball up in the air. The 17 low will have less lead deflection to keep the ball launching a little bit lower. We're talking about a robot here. The droop will be the other way around. The 17 low will have more droop, and the 17 high will have less droop. So you just keep in mind too that the more flexible the shaft, so if we go 17 high to 14 high, we're going to have more deflection and less droop in the 17 than we would in the 14. So as you move around stiffnesses, this works the same way. But here we have the 17 low and the 17 high. So when we look at this next segment, you're going to see how it would make sense that some players would tend to, with the more deflection, hit the ball lower in the face and more towards the heel. And with the low, we would see the ball get pushed higher in the face and more towards the toe. Therefore, you could possibly see somebody hitting the 17 low or the 14 low or whatever series you're looking at low higher than the actual high in that series. And it's usually going to be because that person is hitting it lower in the face. So we always want to know what the player's doing. We want to make sure that we keep impact location at the forefront of our minds when we're doing fittings. Now that you've seen what the droop and the deflection does, you can start to see what's happening when I increase the speed on those two shafts. So I increased the speed about 5 miles an hour on each, and I was able to get 5 shots that were pretty similar, and we can start to see what this shaft is actually doing and what the profiles are doing to it. So by doing that, if you look at the high, 17 high, you know that that's deflecting probably a little bit more. So the club head is more deflected towards the target and there's less droop in that shaft. And so that moved, if we look back at our 17 high point, when it was at a slower swing speed, it was able to be pretty nice right there next to the center. And then when I moved it over to increase the speed, I got more deflection, less droop, and then it moved it lower into the heel. And then we look at our 17 low, you can see it went a little higher and a little more towards the toe. And when we looked at our slower swing speed, it was pretty much in the middle, maybe a little bit higher. But that drooped more, moving it up, and it deflected less. And that's what I know with all the work I've done on gears in the past. So we can see that in this case, as we increase the swing speed on this player, which was me in this idea, would have needed the low instead of the high, because the other way it needed the high instead of the low if we were actually looking for an optimal situation of impact. If you look at those, we got our attack angles the same. Our club path actually went more to the left due to the deflection on that 17 high. Face stayed a little more open, so we hit fades versus the other one went a little more left, and that is a combination now of an increased swing speed. That high face is staying a little more open than what the low is, and keep in mind on TrackMan when I'm looking at this high over here, go back. When I'm looking at that high and I see this face angle average 0.1, basically 0, we are turning that a little more left because it's heel biased. The center of that club was much more positive to the right. So we'll look at some data here. When we're looking at those, let's take out the previous two. You start to look at the lows started to turn the ball over, and the highs started to leave it to the right, mostly because of heel biased hitch. Those may have been just straight pushes, so you can see the torque is also moving that to the right as I increase the swing speed. If you go back to the original two, it was exactly the opposite due to the slower swing speed, and the high was turning it over, and that was probably more due to me trying to slow everything down to be exact than it would be the torque. So those are pretty interesting looks at how the bend points can affect you. We'll go back here and look at a couple of the other numbers. We were able to get the ball speeds about the same. The spin was way higher on the 17 high due to the heel shots and the lower in the face, causing that gearing effect, getting the spin up. And then we got this more in the toe, which lowered the spin of the low just a little bit, not much because it was a higher swing speed and all that, but just lowered it a little bit. And you remember that spin definitely raised up much higher because of those heel shots. The launch, which is interesting now, the low is higher than the high. So it reversed simply because of where I was hitting it in the face of the club. So I hope you enjoyed this video. I hope it helps. If you have any questions, you can sure ask us at tpt.com, and I look forward to doing more videos for you.